Let's graph this rational function. We should always start by factoring to make sure nothing cancels out, even though in this case it's pretty obvious that nothing is going to cancel out. So if I factor the denominator here, x squared can only be x times x, 3 can only be 3 times 1. Inner plus outer equals middle. So inner I have 3x, outer I have 1x. I'm trying to get a middle of -2. So I need a -3 and a +1. So there you go. And it makes -3. -3 times +1 is -3. So there I have factored it and nothing cancels out. So there will be no holes. So multiple choice wise, I can cross out anything that has holes in it right now. So that means the answer is not going to be A because I see that has a hole in it. Okay, that's the only one I can eliminate so far. So let's go ahead and find our x and y intercepts. So let's start with the x-intercept. So on a problem like this that doesn't have any extra numbers on the end, I should be able to just set the numerator equal to 0. But since it's just a constant, which can't equal 0, that means there must not be any x-intercept. So there shouldn't be any. So now let's talk about the y-intercept. I can pull the y-intercept off my calculator. I know it's going to be 0, comma something. Now really, if I wanted to do this by hand, I could do it even quicker. If you substitute 0 in for x, that means putting a 0 here and here. That's going to wipe these terms out. So these terms are gone. So that's just going to leave, this negative sign, I'm just going to put it up here so it'll be clear what's happening. So I have a -2 over -3. So that's 2/3. So it's going to be 0, comma 2/3. Okay, but I could also use my calculator. So we've got this negative, and then I've got 2 over x squared minus 2x minus 3. Okay, and sure enough, 0, comma 2/3. So that's my y-intercept. Let's go ahead and graph that. Alright, so 0, comma 2/3, that means it will be up 2/3 of the way. So it should be right about there. So that's it for the x and y-intercept. Now let's talk about the vertical and horizontal asymptotes. Alright, so for the vertical asymptote, I should be able to set the denominator equal to 0. So if I set the denominator equal to 0, I'm going to wind up setting each of these factors equal to 0. So x minus 3 equals 0, x plus 1 equals 0. So that means x equals 3 and x equals -1. So I've got these two vertical asymptotes. Okay, so I've got x equals 3 and x equals -1. So those are my vertical asymptotes. What about horizontal asymptotes? Alright, horizontal asymptotes are all about the degree. The degree of the numerator compared with the denominator. Now the degree of the numerator is 0. The degree of the denominator is 2. Alright, because of the x squared. And this is degree 0 because it's a constant. It's like having 2x to the 0 power. Okay, so that's why it's degree 0. So when the degree of the numerator is less than the degree of the denominator, that's when the horizontal asymptote is y equals 0. So I'm going to have a horizontal asymptote that's right at 0 like this. Alright, so that's it for that. Now let's plot some additional points. Okay, plotting additional points, it's all about the vertical asymptote. So we have a vertical asymptote at -1. So let's put -1 on a number line. Alright, every vertical asymptote will give me 4 values to plot. So if I went to the left, I'd be at -2. If I went to the right, I'd be at 0. So those are 2 values. But in addition to that, I want the halfway points. So between -2 and -1 is -1.5. Between -1 and 0 is -0.5. So these 4 pink values are values that I need. I already have 0, so check. But I need these other 3. Okay, so I need -2. At -2, I've got a value of -2/5. So that is -0.4. Okay, so at -2, I'm at -0.4, which is right about here. Let's do -1.5. Okay, that's -0.9, almost -1. Okay, so at -1.5, I am just about at -1. Okay, those two are really close together. How about at -0.5? This is the last one I really need. Okay, so -0.5. I've got this. Okay, that is 1.1. Alright, so -0.5, I am just about at 1.1. So it's right about like that. Okay, so I've got those. Now, what else? I've got another asymptote, another vertical asymptote. So that's going to give me 4 more points to plot. Alright, my other vertical asymptote is at 3. So if I have a vertical asymptote here at 3, if I went to the left, that would be 2, and to the right, that would be 4, 2, 3, 4. But in between, I would have 2.5 and 3.5. So these are the 4 values that I need surrounding this asymptote. So let's check it out. Alright, so at 2, I'm at 2/3, which I know to be about 0.7. Okay, so at 2, I'm at 2/3, which should be right about here. How about 2.5? Okay, that's about 1.1. Okay, so it's just a little bit higher. That's right about there. Alright, very close together. And then how about 3.5? Alright, that's -0.9. Alright, that is almost -1. And how about 4? Alright, that is negative 0.4. Okay, so these points are very tight, but yet they're enough to show me what's going on with this graph. Remember, there are no x-intercepts. So I see these 4 points in the middle forming sort of a U shape, but they will not dip down and touch the x-axis, otherwise there would have been an x-intercept. So this must be what is going on, my friends. These 2 points nestled in the corner, the graph has to pass through them, but then it needs to approach the asymptotes beyond that. So it must be doing like this. Okay, same thing on the right. Alright, these are down here, so it's got to approach these asymptotes, you know. And these also, you know, it's going to pass through these points, like making this little U shape, but then it's got to go ahead and approach the vertical asymptotes. It has no choice but to approach those asymptotes. Alright, that was pretty bent. Let me try that one more time. This is very hard with the electronic pen that I'm using. Okay, that's pretty good. Okay, so that must be what this graph looks like. Alright, so let's find it. Well, that's clearly C. Kabam.